Before we keep going in this video, I want to summarize the 4 different types of equations we have been learning about. The first one, of course, is linear equation, and that has a formula, y equals mx plus b, that you learned a long time ago. The next type of equation that you have learned about, and you actually learned about this in the fall, is an exponential equation. Now, I'm not talking about functions right now. I'm talking about equations, and this explicit equation has a formula of y equals ab to the power of x. The next equation that we looked at was that of an arithmetic sequence. And so a sequence is when you have one thing in front of another. It could be a shape, it could be dots, just any type of pattern. We also learned about a geometric sequence, and then these sequences had their explicit formulas attached to them, right? And so depending on if it was arithmetic or geometric, they had a formula that you could use to come up with an explicit formula. So the arithmetic one was y equals a plus d times n minus 1, and the geometric is y equals ar to the power of n minus 1. So I want to go ahead and look at the differences between all these equations. And the first difference that I can think of is the change in rate. When you're talking about a linear equation, this of course is called the slope. It's characterized by the m variable on the formula. And just to review a little bit, the slope is the change of rise over run, the change in y values over the change in x values. And so that's sort of going to be a theme when you're looking at rate of changes in all of these equations. But for linear equations, the slope is rise over run. Exponential equations have something called a constant rate of change, or more commonly known as the common ratio, if you will. And that is when you look at your x values, your range, you're going to come across a common ratio. So the values are changing. They're either being multiplied or divided by a number. That's the same. In arithmetic sequences, you have something similar that's called a common difference. But because it's an arithmetic sequence and it increases or decreases by adding or subtracting, it's not going to be a number that we're multiplying. So your common difference is going to be something that you add or something that you subtract to your y values. In a geometric sequence, however, you are going to have that common ratio. So the change from y values to another is going to be a multiplication number, or you're dividing by a number. So those are the similarities between all these equations, that they have some sort of change that is added to the formula. And of course, arithmetic sequence, you can add or subtract, and geometric sequence, you can multiply or divide. And even though we haven't really talked a lot about exponential equations, but you know that they're going to also be multiplication or division. Sometimes you can't see a constant in exponential equations initially, and we have something called the second degree. So initially when you do the difference, you might not be able to see it, but afterwards you might see a pattern when you do that. And we'll come across those a little bit later in the semester. There might be 2 degrees of difference. So just be on the lookout for that. The second type of similarity between all these equations is that they all have some sort of initial value, right? So when x equals 0, what is y going to be? And so in the linear equation, this is called your y-intercept, right? Or the b variable. So that basically is when we graph this equation, the point that is on the y-axis. On the other equations, they go by a different variable. They use the variable a, but it's basically the initial value. And so sometimes it's not when x is 0. Sometimes it's just when x is 1, whatever the initial value is. So if we're talking about initial population, that would be that first value, that first year. Arithmetic sequence, again, what's the first term? Geometric sequence, what is the first term in the sequence? That would be a, your initial value. So they all have both a change and initial value. Now let's go ahead and look at the differences between these equations. It might be helpful to have a Venn diagram for this, but also you need to be aware of them. The first one is, of course, the graph. The graphs of all these equations are going to look different. In a linear equation, you're going to have a line. So your graphs are going to look like a line if you have a linear formula or a linear function. When it comes to exponential, equations, the graph is going to look different. It's going to look like either a U or a V, and then depending on certain factors, it might even look like a little, just curve, where it looks like it's getting close to the y-axis. I'm sorry, getting close to the x-axis, but not really. We actually call that the asymptote because it doesn't really touch the x-axis, doesn't intersect it. So that's just a fun vocab word for you. When it comes to arithmetic sequence, when we look at the graph, you're going to notice that they're also going to be in the shape of a line. If we were to graph it, right? Though normally we graph arithmetic sequence with a bar graph, if you were to connect the dots for whatever reason, you would notice it would be a line. And of course, geometric sequences, you would also notice that, like exponential, they're going to be in a curve, in a U-shape, V-shape, or a curve. Though, again, we usually use a bar graph to graph geometric and arithmetic sequence. And why do we do that? Well, that brings me to my second difference. The reason we graph them differently is because we have some equations that are called continuous and some that are called discrete. And so the difference between a continuous and a discrete equation is that a continuous equation has numbers or has values that are not whole numbers. So for example, in a linear equation, linear equation is continuous because you have, when x equals 1, you have a y value, but you also have a y value when x equals a half or a third. So it doesn't stop growing just because you're not showing it on the graph. Exponentials, same thing. Especially when we talk about population, right, and things that are growing exponentially, like your bank account, hopefully, it doesn't stop growing because it's a month or 3 days, right? So those values are continuous, so they keep happening for fractions of a whole number. Whereas discrete equations, like your arithmetic sequence, for example, is a discrete equation because you have a first term, a second term, a third term, a fourth term. You don't have term 3.5. So if I were to ask you, hey, does this arithmetic sequence, what's the term 3.5? You don't have one, right? Because you either have a third term or a fourth term, because they deal mostly with shapes or items or things. Geometric sequences are very similar. So your sequences are going to be discrete values, which is why we usually just use bar graphs for discrete values. We talk about the individual term as opposed to term over time, because that is just a linear equation. So that's the main difference. So those are the two main differences between those two. And so after this, we can go ahead and start exploring them deeper and looking at some more features.